Good morning, students. My name is Dr. P. Suresh Babu, working as a professor in Mechanical Engineering Department. As a part of online classes, I am teaching Dynamics of Machinery for third year mechanical students. In this one, we have discussed in the previous class centrifugal governor and watt governor. Now, in this class, we are going to learn about Porter governor. So what is the aim of this class is to derive the relation between Porter governor parameters and also to solve a problem on that one. If you observe this Porter governor, which is one of the classification from the governors. There are centrifugal governors are there, inertial governors are there. Once again in centrifugal governors, we have a one is simple gun, that is watt governor, that is called as a pendulum type. In deadweight type of governors, we are going to have this first classification, that is a Porter governor. So what is the Porter governor? How it looks, what is its functioning and derivation, that is the parameters of this Porter governor with respect to the speed we are going to found in this class, and we are going to solve one problem on this one. So the aim is to find the relation between the Porter governor parameters with respect to speed, and second one is to solve a problem on this Porter governor. Let us have the Porter governor. So Porter governor is a modification of a Watts governor with the central load attached to the sleeve. The load moves up and down the central spindle. This additional downward force increases the speed of revolution required to enable the balls to raise to any predetermined level. So what is this one? If you observe this one, first difference is in watt governor, there is no dead weight at the sleeve point, at the sleeve position. So extra we are going to add some dead weight to bring stability to the governor. First one. Second one, how it controls means when the load is increased on the engine, then governors will try to fall down. At the stage, fuel is supplied to compensate the speed that is fall down. So that is taken care by this Porter governor. To bring high stability, more stability, we are going to have a dead weight along with the bars. Bars will be existing. Along with that one, we are going to have a dead weight also. So if you observe how the Porter governor looks, you can have this one. So this is the Porter governor, and these are going to be the arms as present in watt governor. Here also arms will be present, and these are the balls that is also similar to the watt governor, and this is the sleeve position. If you observe this pink color central load, this will not present in the watt governor. So this is the extra fitting that is added in the Porter type of governor. Next, here ball bearings will be there. From here we are going to be connected to the output of the engine. So if engine load is going to be increased, means automatically the balls are going to come closer, and thereby due to the coming closure there is a change in the bell crank lever, and thereby here the throttle valve is there. This is the throttle valve to supply charge, so that the difference in the load that is compensated here, that will be going to be supplied here. That means here we are going to give the input, and thereby the change in position will take place. Automatically the output is going to be affected here. I repeat once again, the change in position load will be compensated with will be affect on the speed only. The speed has to be increased. For that one, fuel has to supply to the engine. Here this is output, and we are going to control the output with the help of these input parameters. In between this one, for regulation, we are going to have a governor is there. What is the governor function? Governor function is to supply the decrease in speed whenever the load is increased on the engine. So this is the input if we say, and here we are going to get output. And if output is going to be affected means that should be compensated with the input. To compensate that input, in between these two, we are going to have a Porter governor is going to exist. So this is how this Porter governor can be differentiated with the Watt governor. So we are going to add the central load. This is the only difference. Remaining all things are common. So due to this weight, what is the relation that is going to be effect on the Porter governor? We are going to solve it. So this is how the line diagram of a Porter governor looks. These are the arms are there, links are there. This is the sleeve position, and we have represented joining of the two links at the top portion is at the P, and joining of the two links at the bottom portion we are at the sleeve, and dead weight is going to be acted on the sleeve. That means if you are going to raise the height of the sleeve means dead weight has to be considered for lifting that sleeve position. So that is the thing. So this is the line diagram to represent the parameters. So this is the ball, and centrifugal force is going to act. Balls always tends to move outside, and this is the tension in the links. If you observe, this is the height of the governor. Already I told it is the center of the ball to the axis point of the sleeve. Alpha is the angle subtended at the arms with respect to center of the sleeve, and beta is the offset position because sleeve is have certain not intersecting with the axis. That's why this is offset position. So offset position angle with respect to the ball position is going to be called as a angle B. R is the distance between the center of the axis of the sleeve to the ball, and weight of the ball is acting always downwards. Here also two weights are there. That's why it is going to be W. Here weight of the ball is represented by small w. Weight of the sleeve means on two axes two will be there. That's why here we have taken half of that one only. Weight of the sleeve is 100 means capital W by 2 because another half will be at E point. So we have considered only D point here first. So this is the line diagram. This is the parameter representation. FC I have defined W. Capital W is the sleeve weight to the half. H is height of the governor. Alpha is the suspended angle here. T1 is the tension in the arms. T2 is the tension in the bottom lungs. That is from B to D. B to P is the T1 tension. These are the parameters. If you observe, M is the mass of the each ball. W is equal to weight of the each ball. W is equal to mg. That is, G is the gravitational force, that is 9.81. Capital M is the mass of central load. Capital W is the weight of central load, that is equal to M. The W is equal to capital M into G. R is the radius of rotation. H is the height of governor. N is the speed of the ball in RPM. Omega is the angular speed of balls. T1 is the force on the arm. T2 is the force in the links. Alpha is the angle of inclination of arm to vertical. Beta is the angle of inclination of link to vertical. So if you observe this slide, these are the defining the parameters that we have shown in the given diagram. This is how it is going to be looking. So ultimately we are going to solve the relation between the parameters in the given Porter governor. So without friction means N is the RPM, mass of the ball, M is capital mass of the ball, 895 is a constant factor, H is the height of the governor. This is without friction. If friction is included, that is mg, gravitational force will be there. Capital mg means central weight plus gravitational force plus F by 2 forces acting on this one by mg into 1 plus q into 895 h. Here 1 plus q is introduced. We are going to learn this importance of this 1 by q. 3 is h is equal to m plus capital M by small m into g by omega square. G is equal to 9.81. Omega square is equal to 2 pi n by 60, where n is the RPM of the machine. If you observe this one, what is the relation? If you observe, speed is related with mass of the balls and central load and height of the governor. If friction is there, it is going including F by 2. Gravitational pull is there, F by 2, and Q parameter is also introduced. If you want to find only height of the governor, it depends upon the angular velocity of the governor, small m, that is ball mass, and capital M, that is weight of the center. Central load weight, capital M is the central load weight. If you observe this uh, this relation, how we can able to solve this relation, we are going to learn in this class. Let us have this relation for this one. So if you observe this central relation, it is defined like this. The same diagram I have represented to derive the relation between the parameters of the Porter governor with respect to speed of the governor. So if you take same parameters I have introduced for the derivation, that is m is equal to mass of the each ball in kg, W is equal to weight of the each ball in newtons, that is mg. Capital M is the mass of the center loaded in kg. W is the weight of the center load in newtons. R is the radius of rotation in meters. H is the height of the governor in meters. N is the speed of the ball in RPM. Omega is equal to angular speed of the balls in radians per second, that is 2 pi n by 60. N is the RPM of the balls. F is the centrifugal force acting on the ball in newtons, that is given by m into omega square into r. The same diagram, nothing I have changed here. T1 is the force in the arms in newtons. T2 is the force in the link in newtons. Alpha is the angle of inclination of the arm vertical. Alpha is inclination of the link with the lower link. There are several ways are there to determine the relation of the Porter governor with respect to speed. There are two methods are there important, that is method of resolution of forces and instantaneous center method. So we will go for method of resolution of forces because this is the known one and we have solved the same resolution method for Watt governor also. So if you observe the diagram, all of you observe here, there are several ways of determining the relation between the height of the governor H and the angular speed of the balls W. At the following two methods are important from the subject point of view. I am going to concentrate on the method of resolution of forces only. Everyone have a pen with you so that you can also solve the same thing. Listen students. So we are going to solve by method of resolution of forces. So how we are going to solve? If you observe this one, considering the equilibrium of forces acting at D. So this is the D position. So D position, what are the forces acting? If you observe, T2 force is acting capital W by 2, that is center load always acts downwards and angle subtend is beta. So yet here, if you observe, T2 cos beta is equal to central weight half, that is T2 is equal to mg by 2 cos beta. Equilibrium forces acting at D. Next, after considering equilibrium of forces acting at B, if you consider the B forces, At B, the equilibrium forces acting at B forces Fc is acting horizontal in direction. T2 is acting with respect to beta angle. T1 is acting with respect to alpha, and weight of the balls are is going to acting downwards. Then weight of the ball is equal to mg, W small f equal to mg, centrifugal force is equal to Fc, the tension in the arm upper link is T1, the tension in the link that is lower link is T2. So I think clear. So we have one taken D force you have considered and B force you have considered. Now resolve these forces into vertical components and horizontal components. In vertical components, what are the things? We start from here. Vertical component is small w, T1 into cos alpha, T2 into cos beta. So T1 is there, T2 is there at B forces, weight is there, and we have this central weight which is going to be acting at W by 2, that is called mg by 2. Weight of the ball is small w, it is represented as mg. So T1 link is cos alpha, T2 link is cos beta. So based upon this vertical forces, what we can able to conclude, T1 cos alpha is equal to T2 cos beta plus small w, that is mg by 2 plus mg, because is T2 cos beta is equal to mg by 2, already we have written here, T2 cos beta is equal to mg by 2 into cos beta. The same thing we have written here. You try to note down the same thing here, students. Next, horizontal forces. Resolving the horizontal forces at point B. Horizontal forces Fc is there, and T1 horizontal force T1 sin alpha plus T2 sin beta. So these are the three forces which are acting at B in horizontal direction. Thereby T1 sin alpha, T2 sin beta means already we have solved. T2 sin beta we are going to be represented by mg by 2 into cos beta into sin beta. Why? Because in T2, the T2 value is equal to mg by 2 cos beta. Here mg is equal to T2 is equal to mg by 2 cos beta from equation 1. Because by considering the forces at D, we have got that value. Next. So T1 sin alpha is equal to Fc minus mg by 2 into tan beta. This is the equation 3. Because sin beta by cos beta is equal to tan beta. Dividing equation 3 by equation 2. Thereby T1 sin alpha by T1 cos alpha is equal to Fc minus mg by 2 into tan beta by mg by 2 into mg. So T1 by T1 sin alpha by cos alpha means T1 tan alpha, mg by 2 plus mg. That is equal to Fc minus mg by 2 into tan beta. So ultimately, the equation is mg by 2 plus mg is equal to Fc by tan alpha minus mg by 2 into tan beta by tan alpha. We have brought tan alpha for this side because you divided whole fraction with tan alpha. Substituting tan beta by tan alpha is equal to q. So what is the q value? Q is equal to tan beta by tan alpha. Tan alpha means opposite side by adjacent side. From this one, tan alpha means opposite side means radius. Adjacent side is h. So that is r by h. So tan alpha is equal to r by h. So mg by 2 plus mg is equal to mr square. Fc value is m into omega square into r. Already we have defined in the notations. Into tan alpha is h by r minus mg by 2 into q. Q is equal to tan beta by tan alpha. So by using this relation, m small m omega square h is equal to mg plus mg by 2 into 1 plus q. By solving this equation for h, mg plus capital mg by 2 into 1 plus q is equal to 1 by m omega square. By simplifying this equation, m plus capital M by 2 into 1 plus q by small m into q by omega square. So omega square we obtained to omega square is equal to small mg plus capital Mg by 2 into 1 plus q into 1 by mh. By simplifying this equation, we are going to get omega square is once again 2 pi n by 60. So 2 pi n by 60 into whole square. So here we have introduced n. N is the RPM of the bus. So n square is equal to small m plus capital M by 2 into 1 plus q by m into g by h into 60 by 2 pi square. Once again, if you solve 62 into 3.14, that is pi value is 3.14. By solving that relation and g value is 9.81, we got m plus capital M by 2 into 1 plus q by small m into 895 by h. If tan alpha is equal to tan beta, then q is equal to tan beta plus tan alpha by tan beta is equal to 1. If in substitute, that means one value, if alpha and beta angles are same, then we can say that the equation is speed is connected with small m, capital M, small m plus capital M by small m into 895 by h. 895 is obtained from the value of 60 by 2 pi square multiplying with 9.81. So this is the first relation we found between the speed and the parameters of the Porter governor. Speed and the parameters of the Porter governor. Next, when the loaded sleeve moves up and down the spindle, the frictional forces acting on in a direction opposite to that of the motion of the sleeve. So it's obviously it happens. When the load sleeve moves up and down, the frictional force acts exactly opposite to the movement of the sleeve. So there are two forces are there. One is reaction force, second one is normal force, that is active force and reaction force. The forces acting on the sleeve in newtons. Then the equation 4 and 5 and 6 will be written as n square is equal to mg plus or minus f by 2 into 1 plus q by mg. If you observe the fourth equation, we have introduced frictional force only apart from this fourth equation here. Mg by 2, in this fraction we have force is there. The force means reaction forces. Mg plus or minus f by 2 into 1 plus q. If q is 1, once again mg, the equation will be turning into mg plus or minus f by mg into 895 by h. So 895 is once again constant. Already you found how it came. Here f we have added. This is f is the frictional force that is acting on the sleeve. If m is moving up means frictional force acting downwards. If reverse is happening means once again friction, if it is moving down means frictional force acts in opposite direction. Based upon that one, we have to add that sign. The positive sign is used when the sleeve moves upwards or the governor speed increases, and the negative sign is used when the sleeve moves downwards or the speed or the governor speed decreases. So if you observe this one, plus sign has to be added when we are going to move sleeve upwards when speed increasing. Negative sign has to be added when the sleeve moves downwards. So on comparing equations 5th, 6th and 2, that means So Watts governor equation, we find that the center load M increases, the height of the governor in the ratio small m plus capital M by M. So on comparing the equations of Watts governor, we found that mass of the center load capital M increases, the height of the governor in the ratio small m plus capital M by M. So we have solved derivation on deriving the equation for a Porter governor. The aim of the class is to find the parameters of a Porter governor with respect to speed. So we have found that speed. Now we will going to solve one problem on this Porter governor. See, derivation and Porter governor will come for 14 marks. It is very simple to solve this one also. If you remember the formulas, only simple formula is there. The formula is first formula, relation between the speed and the governor, that is n square is equal to m plus capital M by M into 895 by h2 for n2 speed. For n1 speed means h1, that is maximum speed and minimum speed. Let us solve this problem. The arms of a Porter governor for each 250 mm long and pivoted on the governor axis. What is arms are length is 250. Mass of each ball is 5 kg and the mass of the central sleeve is 30 kg. So small m is 5, capital M is 30. The radius of rotation of the balls is 150 mm. So R is given in 150 mm. We have to convert into meters. When the sleeve begins to raise and reaches a value of 200 mm for a maximum speed, that means H1 is going to be 200 for maximum speed. Determine the speed range of the governor. If the friction at the sleeve is equivalent to 20 Newton of load at the sleeve, determine how the speed range is modified. Listen students, here how to find range of speed first, and then if the friction is 20 newtons, and what is the range of speed? Two things they have given. So range of speed in the sense we have a maximum speed and minimum speed. It is given that for maximum speed, height of the governor h is going to be is given as a 200 mm. So this is the relation which we have to remember. What is that relation? N square is equal to small m plus capital M by small m into 895 by h2. So we'll go for, first of all, try to find the speeds. Draw the diagram in a known parameters values and unknown parameters. H2 is, it is given as maximum speed. And where will the maximum speed? When R1 distance is maximum, then we have a maximum speed. If R1 distance is minimum, we have a minimum speed. And it will reflected in H2 and H1. As H2 they have represented. So minimum speed R1 is equal to BG. Maximum speed R2 is equal to BG. So first you represented this diagram. Links they have given, radius they have given 150, and on H2 they have relation. They have given height. So try to solve this one. And small mg, weight of the balls they have given as 5 kg, and capital MG is given as 30 kg. In this relation, H1 has to be found. How to find H1? If you observe this one, H1 is unknown. Hypotenuse you know, base value you know. So based upon hypothesis theorem, PG square is equal to, that means PB square is equal to sum of PG square plus GB square. Out of this one, PG does not known. So PG is equal to PB square minus BG square. Thereby H1 is equal to 200 mm, 0.2 meters. So for N1 speed is equal to M, 5 kg. Capital M is 30 kg. Small m we can 5 kg. 890 by H1. H1 is 0.2. So if you substitute all the parameters, the unknown parameter is only N1. So N1 is 177 RPM. Next, if you go for second one, high to H2, here what they have given 250, here it is 200. Why? In the problem they have given it is 200. For maximum speed, the radius of rotation is 200. Then H2 is equal to be, that means Pg square is equal to Pb square minus Bg square, which is equal to 0.15 meters. So N2 square is equal to small m plus capital M by M into 895 by H2. 5 plus 30 by 5 into 895 in 0.15, thereby 417167. So the square of this value is 204.4 RPM. So this is the minimum speed, this is the maximum speed. Speed range of the governor is nothing but difference of minimum speed minus maximum speed minus minimum speed, that is 27.4 RPM. So there is no very complicated formulas to remember. So we can N1 square is equal to small m plus capital M by M into 895 by H1. For N2, replace with H2. This next. Third concept is if it is given that the frictional force is given as 20 newtons. When the sleeve moves upwards, the friction force acts downwards and the minimum speed is given by. So if you observe, when the sleeve moves upwards means frictional force is going to be acted downwards. Therefore you have to use minus negative value. So mg plus capital mg minus f, frictional force has to be subtracted into its relation is 1 is n into small m plus capital M by small m into 895 by H1 only. As frictional force is there, you have multiplied with g value. Remember student, the difference remember. Then we have to subtract the 20 newtons of frictional force. So if you substitute that one, N1 we can obtain. N1 is going to be N1 speed because unknown parameters only N1. Next, if you go for N2, if the sleeve moves upwards, then add plus instead of negative. Then it is 5.9.81 into 30 into 9.81. Thereby N2 is equal to 210 RPM. So the difference is N2 minus N1 is 210 minus 270, that is 38 RPM. So when friction is there, the range is 38 RPM. When friction is not there, the range is 27.4 RPM. So friction has maintained more difference. So this is how we can able to solve the ultimately. If you observe this formula, this problem, in problem they are given two parameters. Range of speed we have to found is at frictional load and without frictional load. The formula is n is equal to small m plus capital M by small m into 895 by h. If n1 you represented, h is h1. If n2 represented, h value is going to be h2 has to be substituted. H1, H2 can be found by using the simple relation, known relation, hypotenuse is equal to sum of the adjacent square plus opposite square. So that is the relation you have found. So by this relation we have solved ultimately. So before closing this class, I want to differentiate between a flywheel concept and the governor. Flywheel stores energy and gives the energy whenever required during the cycle. It regulates the speed by regulating the quantity of the charge of prime mover. It has no control over the quantity of working fluid. Governor takes care of quantity of working fluid. It regulates the speed during one cycle only. It regulates the speed over a period of time. It is essential element for every prime mover. It is an essential element for a prime mover. It is used in toys, IC engines, hand watches. It is used in automobile vehicles. Already I have explained clearly about the flywheel and governors to differentiate what is the purpose of flywheel. Flywheel only controls fluctuations of energy, but governor will supply the energy to make the into smooth. That is the main thing to understand. So before closing this class, we have discussed about difference between Porter governor and a Watt governor. Second, we have discussed about derivation of this Porter governor. In derivation, relation between the parameters of the governor with the speed. Third, we have found one problem. We have solved one problem. Fourth one is difference between the flywheel and the governor. So by this, Porter governor concept is over. We'll solve problems on the coming classes on different governors. Still number of governors are there. Let us have a royal governor in the coming class. So royal governor will be taught in the coming class. You read this information and solve the derivation. Complete notes is available in Google Classroom code 4FW5XCK. Text messages can be emailed to me chwer5@rediffmail.com. In department link also complete notes is available. All of you go through that one. See you students. Thank you all. Bye. Take care.